Thanks for coming in today, guys. My name is Dougal Shepherd. This is Simon Smith. And for our project, we wanted to understand the emissions of New Zealand's logging operations. So earlier this year, myself, Simon, Johnny, and Pat conducted an investigation into the carbon footprint of one Central North Island company's carbon footprint, and this consisted of 7 crews. What we found from this project is that harvesting operations are contributing a significant amount of emissions as part of the total forest industry's emissions. However, there is currently little research in New Zealand into ways that crews and forest management companies can report on these emissions and on ways that they can reduce them. And so we wanted to extend this project to be a nationwide dissertation. And we came up with 4 objectives for this. First one was to be able to estimate carbon footprint equivalent for harvesting crews in New Zealand. And we wanted to break this into 3 different methods of extraction. That's ground-based, swing yarder, and tower yarder. We then wanted to demonstrate a precise methodology to measure and report harvesting operation carbon footprint. We also wanted to outline the benefits and disadvantages for greenhouse gas reporting for a company within New Zealand as well, and investigate and present current or future methods to mitigate greenhouse gas emissions for harvesting crews.
Alrighty, so getting onto a bit of a method. Initially starting this investigation, we're faced with one big glaring question, and that is what on earth is the carbon footprint and how we're going to apply this to forestry crews here in New Zealand. So, first thing we did, we looked at literature. One of the only real studies that's been done in New Zealand on this has been conducted by McCullum 2009, wherein they looked at the whole value chain of the log. And that's kind of the only real New Zealand study that's been conducted to date. There are a few other field use studies, which we've applied our methodology to later on, you'll see. However, we've based kind of a lot of our thinking off of consultation. So we're lucky enough early on in the process to talk to Lumen Engineering. They're a New Zealand company and they do carbon measurement and reporting. So we got some expert advice from them in an interview, and we're quite thankful for that. Aside from this, we consulted the Ministry of the Environment's guidance. So every year they publish a guidance for forestry companies, for companies willing to measure and report. And we've kind of taken this and going to apply this to forestry. So taking all this information together, we defined our boundary in terms of the carbon footprint as the edge of the forest ground, with a few exceptions. The main one just being the personnel use vehicles on and off site. It's slightly different to that McCullum study in 2009, but we thought we'd keep it simple. If any foresters wanted to replicate this, they'd also be able to follow this. On that kind of same train of thought, we kept it simple to just the fuel and oil usage for our project. We're in a full carbon footprint will include lots of things such as the life cycle of the machines, electricity, wastes, which can be quite hard for just an everyday forester to quantify. Next step, we reached out to a multitude of companies throughout New Zealand in a survey form, and we got a good range of responses. We got about 55 crews responding, and then finally, can't quite see it there, but we put this all together in some nice fancy charts for you guys, which you'll see in a second. Back on the screen, all right. So getting into the meat of the results, this table here, on the left-hand column, you've got your total tonne of carbon equivalent per annum. And again, we broke this down by tower yarder, swing yarder, and ground-based, with the amount of crews represented there. Quite an important finding of our study was to kind of quantify the amount of machines used in each of these crews. So that will kind of give us an estimation of roughly how much fuel is being used, what the utilization was like. We got some results here at the top that show that the ground-based generally had the least amount of machines. These machines are defined as the large-scale harvesting or extraction, not including personal use. Getting to the table, the results there, you can see that for the total tons of carbon equivalent, 1,154 for the tower yard at the most, going down to ground-based at least with 856 tonnes per year. Next, this middle column here, it's quite an interesting column. It's these total tonnes, it's done per metre cubed. So this is essentially showing us how much footprint or fuel use by the same token is burnt per metre cubed log. And you can again see the same increase in trend as you go from ground base all the way to tower yard. Finally, you've got a few measures of variation here on the right, just showing that we have quite a bit of variability in the ground-based data with 62% coefficient variation. So some nice charts. We've got the total carbon footprint here for you guys. Again, that trend of increasing as you go from ground-based to swing to yard is pretty relevant. Again, you can see that total, the box is quite large in the ground-based, indicating that variance. Same thing here, this is the per metre cubed value. So greenhouse gas emissions per metre cubed. Again, increasing trend with a few outliers for the ground base. These graphs here are quite interesting. So it's fitting in at the top, but this is the ground based data. So this is all the 30 ground based crews with a couple of green production things. And this one compares the total carbon footprint in blue with the per metre cubed carbon footprint. This is quite a good finding of our report. When we initially thought there might be some sort of correlation between these two. But looking at that, it's pretty clear there's little correlation, with a few of these large spikes in per metre cubed carbon footprint potentially being attributed to difficult flocks to harvest or just outdated machinery or improper technique. Again, same thing here with the yard crews, the other side of blue, swing yarder and green for cow yarder. Again, no real correlation between total bars and per metre cubed carbon footprint in the line. It's just the vital thing. It'll do.
Sweet. So how do those results that Simon discussed stack up against some of the previous research? So McCallum 2009 and Hoyer 2015 are the only studies done here in New Zealand. McCallum was an alpha study and Hoyer 2015 was a fuel usage participation project done here at UC. We used that data and estimated the oil and crude vehicle usage to come up with these two values. And what you can see is that our values are significantly higher than previous research. However, this aligns with the increase in mechanisation over the last decade in New Zealand. It's important to note the other studies are international, and so they may use different harvesting techniques or process reporting their emissions. So yeah, taking a little bit of grain of salt. Another finding was with an increase in mechanisation, there's an increase in emissions, and we found that as well. We also wanted to outline some of the pros and cons for a company within New Zealand to report their carbon footprint. So some of the key benefits we found were that you'll be prepared for potential disclosure requirements. You'll potentially be able to reduce your costs long term. There's better financing options available due to the green sustainable loans the banks are now giving, and you'll help meet our nation's targets by the government. Some of the key negatives are the time taken, the costs associated with that, and not necessarily making action occur. So what I mean by that is they may be able to measure and report your emissions, but it's not actually forcing you to do anything at the moment. And this is what we found through our survey results as well. 4 of the 6 forest management companies we talked to measure their carbon footprint and include the fuel data within that. However, most companies are still in that quantifying stage and have little reduction plans put in place. Another finding from the survey was that currently it is the forest managers that are doing the reporting. There's actually no pressure on the harvest crews to report. We also discussed quite a lot on reduction options for forest management companies and harvesting crews, and we went into some that were shorter term options and longer term. The 2 near term options we looked at were biofuels and biodegradable oils. Biofuel has been pretty extensively researched in New Zealand, and the opportunity to use biomass has been studied by several people. However, uptake is still relatively low. And the reason for this is the cost of it. It's currently around 2 times more expensive than traditional diesel. And after speaking with the Z Energy representative, he stated this was from high transport costs and high global feedstock demand. Biodegradable oils were another option we looked at. They're really suited to forestry operations due to the uncontained environment. However, uptake has also been relatively low due to the per litre cost. However, research 2016 found that it's actually 6% cheaper than traditional oils because of the decreased volume that you require. The biodegradable products can also be carbon neutral. For example, Blue Eco's product there. However, they say the uptake, the most likely uptake is from a mandate by the government or council, similar to what we're seeing for biofuel coming in next year. Two of the longer term options we looked at were electric hybrid engines and hydrogen fuel. We're beginning to see the integration of electric hybrid engines in forestry machines, and there's currently one machine working in New Zealand. That's the Logset 12H GTE, which is a harvester, and it's been reported to have between 7 and 30% of fuel reductions. Through the report, we also outlined or looked at a number of other different machines. They included some cable yarders and also porters.
So looking at the other long-term option we considered, this was hydrogen. So hydrogen's had quite a bit of talk and excitement in the space, and a few of the forestry companies are actually starting to look into this. We do know that Manulife has a hydrogen truck on the way, so they're starting to invest in this technology. As far as the equipment goes for hydrogen, it will most likely start with the trucking sector, as we're beginning to already see. Through the course of this analysis and investigation, we had the opportunity to talk to a few companies, one of them being Hidinga Energy. So they're taking this prospect of hydrogen quite seriously throughout New Zealand. They're investing in the infrastructure side of things. So on this diagram on the right, it might be a bit hard to see, but the orange dots essentially are the 4 refueling and production stations for hydrogen in the North Island. They're currently under construction, and with another 20 planned by 2026, we will soon have nationwide coverage. So this raises the question of how and when we're going to integrate this potentially into the forestry industry. It will start with trucking, but there are some talks in the design phase for yellow equipment, so on-site equipment. However, this is still at a glance maybe 3 to 5 years away. All in all, we've got hydrogen in the category of one to keep an eye on. So it's definitely coming, but it'll be a bit longer down the road. There's still a few things that need to be nibbled out before it becomes mainstream. So all in all, we demonstrated and developed a methodology for a simplified carbon footprint just based on that fuel and oil usage, and we applied this to forestry crews in New Zealand. In the report, we detail into it, and it should be fairly easy to follow through for a forestry crew here in New Zealand, just keeping it that simple. We got some good data, so we've got 55 crews that replied. We've got averages of the per meter cube values, so 13.1 for ground-based, 15.6 for swing yarder, and 18.1 for cow yarder, indicating that as you go up that mechanization and through the extraction method of cow yarder, the per meter cube carbon footprint increases. We identified that there's an increasing pressure to measure and report emissions, and we outlined a few early benefits, those that are willing to get ahead of this curve. Finally, we touched on some future innovations with a short-term outlook, most likely including some biofuel, bio-oil solution, and longer-term, potentially electric and hydrogen coming into play. So a huge thank you for listening today, guys, and we'd like any questions. Great.
I'll just go stop share so that we can see the participants again. Yeah, so we can see everybody. And again, great for people who have zoomed in. Yeah, questions. We've only really got time for 2 or 3 questions. We like to keep it on schedule. But yeah, if anybody's got any questions.
Yeah, I've got one for Dougal and Simon.
Yep.
Guys, yeah, congratulations. Good presentation, and obviously a really topical and interesting subject. My question for you both is, where is it going to go from here? Your study, I mean, where are you going to go from here in terms of further work?
So yeah, Dougal's off shooting after work next year, but I'll be sticking around at uni. So I'm staying here for a master's, and I guess I think the question to me will either be to expand this or to kind of attack it from a different angle, perhaps pursuing one of these innovation options that we talked about, such as the long-term solutions. But I think I have to talk to Rain and figure out exactly what I'm going to do.
Cool. Okay. Cheers.
Yeah, Nathan.
Okay, so I sort of noticed to me that the tower is obviously quite a lot more than the swing yarder for its carbon footprint, well, its used emissions there. I might have missed it, but any real specific trends there and why you think that is?
I think most of it will come down to the type of block, the different crews that are harvesting. For example, for the ground-based crews, a lot of them will be easier terrain, so they'll get quite an easier volume per the amount of fuel burned. Whereas with the tower yard crew, they're obviously having to move the machines around, move the wedge machines down quite a bit. And I think that's probably the main contributing factor within the terrain, which we weren't necessarily able to capture within the scope of the study. But yeah, terrain would be the most likely difference.
But sorry, just one other factor was the number of machines, right? So ground-based, you had, what was the average number of machines for
Great, yeah,
ground-based?
so I think we had an average of 4.8 machines on site. Yeah, that was something we tried to capture too. And averages were much higher machines on site for the swing yard and tower yard. I think it's 7 and 8. Yeah. So yeah, from the number of machines on site, I guess you can see there's a bit more fuel being burned and oil being used and whatnot.
Okay, one more question. Yeah,
The manual hydrogen, is that hydrogen injection or something fancy?
Hydrogen fuel cell.
Yeah, right.
Yeah, yeah,
Awesome.
yeah. That's on its way. It's pretty exciting. Yeah.
all right, so thank you very much, Simon Dougal. Appreciate your input. Excellent work.